So for today, we will check on the stability. Okay. Kenapa? Okay. So for today's lecture, the course outcome, you should able to apply the theory of lateral earth pressure, okay, and slope stability. So you already learned the slope stability with Dr. L, right? Okay. To determine the stability of the natural or man-made of slopes, unsupported or supported by earth retaining structures. So actually this topic will be the combination of checking the stability of retaining wall and also calculating the lateral pressure using Rankine or column theories. Okay. So these are the branches of earth retaining structures. I think you can read this by yourself. There are internally and externally stabilized systems. So mungkin most of you saw you already counter gravity walls, which is using concrete untuk retain the soil, macam flyover, something like that. They also can have anchors, soil nailing behind it. So it's internally stabilized system. So I think you can find this everywhere. Okay, so the in situ walls, externally stabilized system, where we can see sheet pile walls. Okay, so this is the sheet pile. This is you can use as normally people we use is temporary retaining system during the construction. Okay, let's say you have a construction here, and then you want to retain the soil from the roadside to avoid it collapse. So you retain using the sheet pile. Okay. Sometimes people will put the sheet pile first, and then dia akan letak the other retaining structures, let's say concrete or whatsoever, for the permanent structures. But also can be used as permanent walls. So these the other examples. In situ second pile walls. Second pile walls mean you will learn this in next semester in the design, foundation design, whereby the second pile walls ni dia ada male and female. The lecturer will, dia ada something like this lah. Dia ada male and female pile walls. This will we call second wall lah. Okay, so this made in situ, di mana you will put your you will install your reinforcement bar, and then you also put the concrete in situ. This is soldier pile wall. This is all the example of externally stabilized system, di mana dia hanya retain. Okay, this is the excavation. Okay, I want to change the color. This one. Okay, this is excavation. Ini yang kamu retain. Okay. So the pressure, the lateral earth pressure come from the retained soil. So you are excavating here. So you put the retaining structures to retain the soil from disturbing or collapsing to the excavation part. Let's say here you want to construct basement parking. Okay, so externally means yang ni hanya retain from the outside. You tak ada install apa-apa untuk, let's say macam geotextile or soil nailing or anchor bolt, something anchorage into the soil to in order to help to retain. Okay, itu maksud externally and internally lah. Ini salah satu contoh lagi gabion wall, whereby we use stones, batu untuk retain the soil behind it. Okay. In order to choose whether you want to use externally or internally stabilized system ataupun retaining wall ni, you have to calculate correctly your lateral pressure. And then it's also depending on the height and the ground environment system lah. We will go through at that later on. So these all the examples. You may use this retaining wall, depends on your case in your IDP project next semester. Okay, you are second year or third year. You are second year, right? Not yet. Next semester you will learn on the foundation design. Yang tu akan belajar juga macam mana nak design on the links itself and also the reinforcement bar dalam tu. So for this geotechnique, you only want to calculate the lateral pressure saja. So this is the examples. I think I can skip this one. It's actually all the example. Okay, ini internally. Internally means you are installing something inside the retaining soil. Ini contohnya soil nail wall. Okay, soil nail wall, they will insert into the retained soil and then they will put something like macam paku or anchored in order to it macam tak lari lah. Okay, so these are the example. So this is anchored. Okay, it means when you put only, let's say, only the gabion wall here, but then based on the calculation or the analysis, the slope still fell. So in order to increase the factor of safety, later on you will learn how to calculate factor of safety. You dah belajar dalam slope stability, right? So in order to increase the factor of safety, in order to meet the requirement by the authority, so you have to increase ataupun you have to install the internally stabilized system into the retained structure. Okay. Okay, ni the installation procedures lah. Okay, to install the soil nails. You may read this further in textbooks or papers. Okay. So this is the same thing. This is geotextiles. Okay. Geotextile is something like carpet, macam carpet, tapi dia made from fiber. Okay, it is very strong and also used as the drainage system, reinforcement system. Okay, yang ni banyak digunakan di dalam construction. Or separator. Okay, separator. Let's say to construct a rod system, you have subgrade, sublayer. There's a few sampai you atas sekali pavement. So normally from the foundation system, foundation part will be the subgrade. Okay, from the subgrade into the other part, dia by layer, ada subgrade, sublayer lagi, subpavement, and then the lastly pavement lah, yang asphalt tu. So kat situ dia akan install geogrid or geotextile as the separator. Okay. So this is the construction of retaining wall. Okay. Okay. Macam-macam lah cara dia guna untuk install retaining wall. So this is the details. For this lecture, we won't include the design of retaining wall. Kita hanya analisis sahaja. Okay. So these are the forces acting on the retaining wall. Ini yang kita belajar hari tu lah. Okay, we will check the safety factor of safety based on the calculation of the lateral pressure. Okay, this is the active pressure, lateral pressure. Okay, the sliding friction, the passive pressure, and the active pressure. These are the main forces on determining the stability of the retaining wall. So this is the condition of pressure at rest. Okay, so this is the height of the wall. Okay, so this is the backfill. So the soil, we try to exert the lateral pressure into the wall. And then the pattern of the lateral pressure will be, will be 0, and then the bottom part will be the highest value. Okay, so these are the formula to calculate the lateral pressure. It will be involve the density, so the parameter at rest, okay, the lateral factor at rest, and H. Okay, so kita dah belajar active and passive, right? So in order to understand all this, you can refer back to your notes to calculate the active and passive earth pressure later on. So this is the design considerations for retaining walls. Okay, you have to look into the dead weight of the stability of the walls, gravity walls, and also the embedded walls. Nanti kita tengok apa maksud gravity, apa maksud embedded walls. So these are the categories of retaining wall. Ini yang saya cakap tadi. How we want to choose whether you want to use concrete retaining wall or a sheet pile wall or a second pile wall. So it depends on the environment or the situation of the engineering problems. So the first and foremost will be the soil parameter and your groundwater condition. So ini penting lah. You can refer to any YouTubes or papers that discussing on the problems of when you construct the retaining wall, apa masalah-masalah dia, and then apa you have to encounter. You can do refer further to the other textbook or papers or website lah, paling senang. YouTube pun banyak Okay, so height and ground of topography. So it means that you nak install, you nak construct the retaining wall tu kat mana. Let's say you want to cut the hill and then you want to construct a road there beside the hill. So how to make sure the one that you cut just now not collapse to the roadside. So you have to retain or the wall or not. So in order to calculate that, okay, let's say this is the hill. You want to cut this part. Okay, so this is the longitudinal section. Kalau cross section, you already cut that part, and then this part will be your roadside. So what happened to this part? So this part, you dah disturb dia punya in situ kan. Mula-mula dia macam ni, and then you want to install the rod. So you cut here, and then this, what happened to this? Is it stable enough? Okay, sama ada dia tak collapse atau tidak. So you have to calculate the lateral pressure, and then there and check the factor of safety sama ada you want to put the retaining wall or not. Okay, so it depends on the topography and the height. Okay. Kita ada small retaining wall or big retaining wall, depend on the height of the system. Okay, so this is availability of suitable fill material. Ni maksudnya, let's say, kawasan kamu bawah, dalam pula. Okay, so maybe previously there's a river here, and then within 100 years, yang ni semua hilang. Okay, ini semua hilang. So you want to construct construct a residential apa ni, houses kat sini. So you have to fill this area. So this will be the area will be whether you want to retain or not. Okay. The fourth one, construction constraint. So depends on the specialist technique, equipment, space, access. So depends on this is we can say also the cost lah. Kalau kita ada cost yang tinggi, kita bolehlah upah specialist techniques ataupun use the high-end equipment whatsoever. Okay, environment, impact during construction. Let's say there's a different situation bila you want to use ataupun you want to install retaining walls in something like dekat kilang yang jauh daripada bandar, and then compared to the one that you want to install retaining structures in the city. So there's the environment impact there. Okay, the ground movements, this is adjacent structures, you nak letak ini kena consider lah sama ada rumah sebelah-sebelah kamu tu bila you nak buat all this excavation, dia tak settle or not settlement. So ini will be the settlement issues. So underground obstruction and services maksudnya pipelines, water pipelines, sewerage pipelines ataupun tiang elektrik, all this lah. Okay, the design life and maintenance requirement and cost. So this is more to related to the authorities also. Okay, so this is the general step to design. First of all, soil parameters. Ni macam biasalah. Trial and error. You tak tahu the size of wall that you want to design. There's a rule of thumb to determine the sizes of retaining wall lah. Okay. Okay. Calculate the destabilizing forces acting on the rear of the wall. So ini maksudnya lateral earth pressure tadi. Okay. And then the resultant of destabilizing forces and the self-weight of the wall. Lepas tu baru kita check factor of safety. Yang ni you dah buat juga dalam slope stability, di mana factor of safety means the moment of forces of resisting. So resist over the overturning or sliding, something like that lah. Yang ni adalah yang menyebabkan dia, yang trigger dia untuk failure. Ini adalah benda yang membantu untuk stabilize the structure. So you kena check by overturning, sliding and overall failure. Normally we will do bearing pressure jugalah. So this is the trial and error to determine the size of the wall. Okay, so retaining structures ataupun retaining wall concrete normally is something like this. Okay, let's say okay, how to determine this distance? How to determine this distance? How to determine the height? How to determine the width? Semua kita tak tahu. As a designer, you have to have a rule of thumb to determine what are the value of these retaining structures. Okay, how? So these are the rule of thumb lah. Okay, ini adalah rule of thumb to design or to come up with the initial dimension of retaining structures. Okay, so kita tengok ni minimum better. Ini size dia D/2 to D. Okay, this is H. Apa ni? Okay. So normally we have H, right? Okay. Let's say kat situ kita tahu the height of the ground that you want to retain is something like 2 meter, 3 meter, 4 meter. So the other dimension we will relate on the H. Okay, ini adalah initial start kita nak design. Okay, kita tak ada when your boss later on ask you to design, you cannot ask him what are the sizes. So these are the rule of thumb in order to design the size, and then baru you calculate your resultant forces into the structure. So daripada situ baru you can nanti come up with the FOS. So this is the example of gravity wall. This is the cantilever wall. Okay, cantilever wall maksudnya dia ada ekor kat sini, panjang sikit. So these are the earth retaining lah. Maksudnya tanah ni dia dibantu untuk tidak collapse because of the weight of the concrete. This concrete akan retain the soil. Okay, maksudnya kekuatan konkrit ni lebih besar daripada kekuatan tanah untuk collapse. Something like that lah. Okay. So these are the further consideration. Normally the important part will be the water. Okay. Let's say I give you examples that we have here. Okay. In what we call it, Plaza Merdeka punya shopping mall. Okay, I know you know that, right? Okay, there's a basement parking. You know that the basement parking is actually apa ni, sama level dengan sungai yang kat bawah tu. So it means that how you want to retain the groundwater ataupun water into the construction before that. So that's the important part lah. Okay, you are considering the environment. Okay, bila you nak correct, okay, this is the ground level. So you know that here, next to here is the sungai that will be turun, there will tidal and rise effect. Dia akan tidal, naik dan turun. Okay, so you want to construct your basement parking here. So that's happened to the Plaza Merdeka lah. One example of yang macam challenge the nature. So you have to consider water, dia bukannya sungai tu kat sini saja. Dia akan ada seepage. You ada belajar seepage kan previously with Dr. Linda. So it will be when you disturb the soil here, you want to do the basement parking. So it will start. Dia akan cari mana tanah ni akan start to macam ada, because you already disturb here, dia akan start to macam tolak lah. Sebab kat sini kosong kan. Before this, you tak ada kaca apa-apa. And then you start to excavate here. So before that, it cannot. You just excavate, tolak. Buang-buang tanah macam tu je. Okay. First you have to install the retaining structures. Excavate sikit-sikit, install kat sini. Excavate lagi, install kat sini. That's the construction procedure. Okay. This lecture will not that up to that ni lah. Okay, you will learn it further in the next semester. on the design itself. Okay, this is the apa ni examples in order to draining the water when we have, this is the soil, you want to drain the water. We know that musuh utama untuk soil ni adalah air lah. Air tu yang memberi beban yang ekstra kepada soil tu, and then reduce the shear strength. You already learned on shear strength last year. Okay, and then how to increase the shear strength and remove the water. So you can drain out the water using these methods lah. Okay, so these are the failure mechanism which you have to check on the factor of safety later on. The first one is the sliding. Okay, or some books they put it translational translational checking. Okay, sliding lah maksud dia. The second one will be overturning or rotation failure. Okay, the third one is the bearing capacity, which means kekuatan tanah di bawah struktur kamu. Okay, so nak check yang ni, semua kena kira lateral earth pressure. Yang ni kena, penting. Okay. Any questions? Am I too fast? Sekejap Any questions? You can enter the chat or question in the message. Tak ada Can I just proceed? Hello? Okay.
Madam.
Ya?
Buka page sebelumnya tak, madam?
Buka page sebelum.
Oh.
Saya ni tak berapa pandai sikit, kejap. Okay. This one? Okay.
Sliding dengan overturning tu apa beza ya, madam?
Oh, sliding will be at below this, kat bawah ni. Dia akan bergerak, move. Kalau overturn, this is toe, right? Ini toe, in heel. So it will overturn due to the moment. Kalau sliding ni, dia bergeser kat bawah ni. Maksudnya, structure tu, dia tak lock lah. Dia berat tanah ni lebih besar daripada berat structure ni. Dia akan slide. So tak ada friction kat sini lah. Friction ni tak cukup kuat. But for overturning, it's a moment. So it will be measured, this is the force and didarab dengan distance kat sini nanti. Tuto, moment. Tak samalah, ini force, sliding. Kat bawah ni sahaja. Kita kena check 3 benda ni. Okay, for the factor of safety, check by the sliding, which is the forces. Okay, and then overturning will be the moment, and the bearing capacity will be the foundation. Okay, saya rasa siapa yang dah ambil foundation engineering, they will know how to calculate the bearing capacity. Okay, understand?
Okay, boleh.
Boleh Okay, tak apa, lepas ni the end of the slide ada contoh kan? Kita akan go through tu. Okay, we can start Okay, ni contoh-contoh tadilah dia nak tunjukkan lagi macam mana sliding tu, apa yang berlaku. So this is the potential external stability problems in cantilever retaining wall. The first one will be the sliding failure. This is sliding. Tengok dia lari daripada kedudukan yang kita nak design. Okay, overturning will be the topple failure. Okay, dia overturn. Tengok dia overturn at one point which is at the toe. So later on we will measure ataupun we will calculate the moment that caused the retaining structures to fail to the toe. Maksudnya kita kena cari the F and then you have to know the distance from the pressure that exerted to the wall to the toe. Sebab dia akan fail dekat toe. Dia tak akan fail dekat heel kan. Okay. So this is toe and heel. So because heel mana ada dia? Ni tak ada apa-apa. So yang ini yang akan tolak the structure. That's the overturning lah. Okay, the third C will be the normal force acting on the base of footing, not within the middle third. Yang ni normally the lateral pressure, we are assuming that the pressure will be acted on the 1/3 kan. Okay, so ini adalah keadaan di mana this normal force acting not within the middle third. Okay, so the fourth one will be the bearing capacity failure. Apa beza ni bearing capacity dengan yang overturning tadi? Bearing capacity maksudnya kekuatan tanah di mana kamu letak retaining structure itu. Okay, foundation lah, the foundation, the soil. So this is happen due to the settlement problem. Yang ni you dah belajar masa consolidation kan. Settlement ada dua. Immediate settlement when you construct the structure, maksudnya just after you construct the retaining wall mesti ada turun sikit kan tanah tu. Tapi when comes to consolidation, along with time dia akan ada settlement juga. Okay, so settlement will be one immediate just after you construct. The second one will be the consolidation, which increasing with time. Okay, you kena ingat yang ni lah. This is the important part. When we design, we will go to settlement or stability. Itu saja. Kalau geotech, memang kita nak tengok dia settle within the permissible settlement or not. Dia stable or not. Okay. So this is the mode of failure lah. Okay. Yang ni lain topple. Yang ni dia turun ke bawah dahulu and then the soil will push it outside toward the knee. Yang ni the pattern of, you can see the pattern of failure for bearing capacity is different, that which you will learn it further in foundation design, shallow failure. Tengok this is the pattern of failure. Yang ni you akan nampak lagi nanti you akan belajar during shallow foundation. This foundation, dia akan fail, the failure will be like this. So it's the shear failure. Okay. Okay, yang kelima ni adalah deep sheeted shear failure. Apa maksud deep sheeted ni? Deep seated saya ni asyik macam bunyi lain je. Deep seated. Okay. You know, you already learn slope failure, right? Slope failure. Slope failure maksudnya in terms of limit equilibrium. Okay, di mana you know that this is the there's a shear strength tau, what we call it, sigma tan tambah V tambah C kan. Okay. So this is the strength of the soil that resist the failure. Ini that cause the failure. Okay. So this one will be lawan balik, resist the triggering factor. Okay. So you will estimate estimate the failure based on the soil parameter, right? Kalau sand, lain bentuk dia. Kalau clay, will be circular failure. Ingat lagi tak? You learn with Dr. Al kan? Kalau sand, the failure will be terus jatuh macam tu. Okay? It will be sheared at the friction angle. Okay? But for the clay, it will be the circular failure. Okay? These are the two differences lah. The difference between the sand and clay. Okay, so sekiranya you're not considering this limit equilibrium or the slope stability problem into this condition, you design ni tak cukup, dia fail dekat dalam, you estimate kat sini, so bila ada retaining structure ni dia akan tahan the failure ni lah. Tapi bila you salah design, is actually fail at the back. So it's actually fail at the deep seated more lagi. So bila dia fail kat sini, tak ada benda ni tak cukup dalam lah. Dia tak cukup untuk resist ni kan. So yang ni akan jatuh sekali. This we call it deep seated failure. Okay. So the last one will be your excessive settlement. Maksudnya failure in bearing capacity lah. Okay, sama lah ni. Dia akan turun ke bawah macam ni. Masuk ke bawah tanah. This is normally for soft lah. Okay. So this consideration will be taken into account when you want to design retaining structures. Okay. Okay. Okay, so this is the sliding, the first mode of failure. Okay, the first checking, okay, sliding. The mode of failure where the wall slides because the frictional forces is less than the force due to difference in the active and passive pressures. Maksudnya force yang kat bawah ni, okay, we know that these forces or the resistant forces, the friction, dia akan membantu untuk the structure retain at itself. Tapi bila kita ada ni, this friction between the wall, between the base and the soil bawah ni adalah less than yang ni, tolak ni, okay, it will be fail. Itu maksud dia lah. Force, the difference between active earth pressure and passive earth pressure. Okay, maksudnya forces yang ni, balance antara dua ni lebih besar daripada yang kat bawah ni. Yang kat bawah ni actually depends on the frictional material ataupun the material that you use. Sama ada you use batu, you use concrete, you use steel. So it depends on that. Okay. So normally this one, it will be depending on the passive earth pressure. Kalau passive earth pressure ni besar, it will helps to counter back the active one. Okay. So overturning is the rotation. Okay. This will be very critical when it comes to very high retaining structures. Wall height becomes very large. So there's you are allowing some moment due to, at the toe with respect to toe. Okay, kalau maksud dia, okay, this is your structures. Okay, let's say so this is your toe. Okay, bila yang ni your height is very large, okay, there will be a moment bila ada macam orang tolak you dari belakang, semakin tinggi kamu, semakin senang lah kamu nak topple kan. Kalau kamu tak berat lah maksud saya. Okay, so there will be overturning or rotation with respect to toe. Significant moment. So this force comes from the lateral pressure, multiply by the height of the wall with respect to toe will induce a moment that will cause the overturning failure. Okay, itu maksud dia lah. So in order to resist the moment, sekena your structure ni kena cukup berat lah. Okay, and then let's say there's a passive pressure juga kat sini untuk balancing the moment, the destabilizing moment due to the height of the wall. Okay, so the last one, the bearing capacity is stress due to the weight of the wall. Kalau terlalu besar pula, you will worry on the bearing capacity of the foundation where it can last the weight of the structure that you want to retain. So there's these three things, these three factor stability concern, it's counter each other. Kalau terlalu besar, your concrete terlalu besar, okay, dia ada masalah bearing capacity. Dia tak boleh juga terlalu besar. Let's say over design for the overturning. Let's say for the overturning it check FOS. Tapi bearing capacity fail. Tak boleh juga terlalu besar. Okay, so it must be optimum design which fulfill the safety for the three concerns just now. Sliding, okay, overturning, and also the bearing capacity. Okay. So overall stability is depending on the slope stability. Okay. Okay, kita kena tengok stability overall di mana tak ada berlakunya deep seated failure macam ni. The stability ataupun the slope failure macam ni, you kena turun lagi ke bawah untuk design. Tapi kalau slope stability is something like this, only shallow, so it will be enough for you to construct the retaining wall structure. So this retaining wall, bila ada potential of slope failure kat sini, yang ni akan resist kan, dia akan tolak, it will be not. Jadilah benda ni. But if you are calculating salah, analysis pun salah, you design macam ni tapi failure sebenarnya deep seated, it will be total failure. Okay. Any questions? Okay, because there's another example at the back. Kita nak go through yang tu. Okay, so this is the same thing, the limit stats. Limit stat maksudnya macam mana nak go back to that one? I don't know how to use this. Sekejap Okay. The limit stat maksudnya yang paling the limit lah. Okay, the threshold for the stability. Okay, moment resisting over moment overturning, or force resisting over force friction, let's say. Okay. Deep slip surface which envelops the structure as a whole, soil and wall deformation, seepage effects, Yang ni yang saya cakap tadi, conditions of water seepage from the river. So this is very important for dam design. Okay, dam design, parking design. Kalau you nak parking dekat sungai, macam tu lah. The seepage water and structural failure. So this is the the limit state for the sliding. Okay, nito, nihil, this is the width. Okay, example of gravity wall. So the weight will be the one that resists the structure to fail. Okay, semakin besar the structure, it will be dapat counter the weight of the soil. Okay, tapi bila semakin besar structure, you kena consider the bearing capacity check pula. Okay, so kena optimum lah design. Tak boleh over design kat sini, yang ni pula fail. Over design kat bearing, yang ni tak fail tapi topple. Okay, so this is the examples of how you want to increase the safety ataupun factor of safety when you design a retaining wall. Nak besarkan the structure, or you want to provide the key. So the key is actually lock the soil. Macam ni macam foundation ni lah, dia masukkan kat dalam tanah ni untuk lock, increase the bearing capacity. So yang ni tak akan gerak. Or you can use, kalau you want to do a filling, or instead of cutting the hill, you are filling the one filling the embankment. Okay, embankment, you use stronger backfill. You tak buat guna clay lah untuk jadi backfill. Kalau you guna sand with high frictional material, it won't be. There's a drainage system there, and then high friction angle, so it won't be a problem. Okay. Or you can extend the hill. Kalau ni tak cukup panjang ke dalam, extendkan lagi. So there's the options of install all these method of improving sliding stability. It depends on the cost, okay, the environment, okay, the adjacent structures. Kalau kat tepi-tepi kamu ni bangunan apa semua, is quite difficult lah. You have to counter the noise of everything, all this lah. So this is the cara to improve the sliding stability. Bila dah ada macam ni, dia tak ada potensi, maksudnya the lateral pressure will be retained by all this lah. Okay. So this is to design the key between the footing and the stem. I won't go here to design. Nanti ni kamu belajar nanti dalam foundation engineering. Okay. So in cantilever walls, okay, if using Rankine earth pressure theory, it involves drawing a vertical line AB through the point A in the next figure located at the hill. So this is how to estimate sebab apa yang kamu design. Okay. Ini contoh kalau you want to design a cantilever wall, this part will be infinite kan. Dia akan sangat besar. So macam mana you nak kira sama ada benda ni akan stable or not. So based on Rankine theory, normally where we want to consider, so this part, okay, highlighter, this part. So these are the limit to calculate the earth structure. the soil, the retaining soil. So kita hanya consider yang kat sini, up to the hill that you want to design. Okay? So sebab yang ni infinite kan, you tak tahu sampai mana, ni sangat-sangat besar. So normally how to calculate the lateral earth pressure, we take into up to the hill only. So these are the lateral pressure that you want to calculate, or the weight. Okay? So this is if you refer to the notes sebelum ni, okay. When you want to calculate the lateral earth pressure, the basic one, you have this flat, yang ni tinggi, and then you want ni, the soil. So the soil will be like this kan. Okay, yang ni kita dah belajar. Lepas tu, the pressure. So why this one like this? It's actually imitating the, I'm using the, you can refer back to your notes, the Rankine and column theory notes. Okay, this one is actually the alpha. Okay, so the earth pressure diagram is actually depending on the slope ataupun yang ke atas ni, the ground level. Okay, kalau ini flat, so your lateral pressure will be flat like this. And then kalau ada macam ni, ada angle, so the angle will be like this. Kalau ada air kat sini, it will be like this. It will be the water. Okay. So all these things, ni nota-nota yang saya dah bagi masa before MCO tu lah. Okay. So in order to check the FOS, kita kena buat line daripada here ni pergi naik ke atas. So this part are the one that you consider to calculate. Okay, and then you will draw the earth pressure diagram according to the ground level and the condition. But normally, kalau ada surcharge lagi kat sini, let's say kalau ada pavement kat sini, uniform load. Pavement will be uniform load. So this will be ada extra, tambah lagi satu kat sini will be the, okay, ini air tadi kan? Ini air. Kalau ada rod structure ke atas, tak adalah macam ni is lain lah. Tambah lagi satu, uniform load. Okay, so this will be contributed by the uniform dead load of, let's say normally is pavement. Okay, so this will be considered in the design or the checking. So these examples, you can see here. Tengok. Okay, so the weight of the soil that helping is actually from this side. Okay. This one, for a small retaining wall, there will be a semi-empirical chart. Okay. For small returning wall, kita ada charts. Kita guna charts lah. That already provided in the standards. Okay, so these are examples. Yang ni you can go through by yourself. I want to emphasize on the how to calculate the safety checking. Okay. Okay. Yang ni boleh refer to extra exercises and then try to use the charts untuk semua retaining wall. Saya nak kita go through the safety checking lah. How to check the overturning, how to check the sliding and also the bearing capacity. Okay. So any question so far? Ini yang assignment kamu nanti Any question? Can put questions here. Sebelum kita go further, ada soalan? No Okay. So these are the procedure how to determine the safety checking. Okay, for overturning, tadi saya ada mention on overturning about the toe. Okay. Banyak orang left the meeting. Okay. For overturning, okay, you kena kira the moment, right? Okay, so this is the small r here is representing the resisting moment. And then O is the overturning moment. So this is the factor of safety. Sum of moment of forces tending to resist the overturning. Okay. And then MO is the sum of moment of forces tending to overturn. Okay. So generally, that tend to overturn will be introduced ataupun triggered by the lateral pressure lah. This is the lateral pressure. Okay, I use the different color. Lateral pressure, whereby you can calculate it based on PA cos alpha. So this is referred to the previous gambar. You can check on the previous page. Ada back. Salah. Ada back. Okay. So this is the example tadi. So the one that overturn, this is we call it toe. So this is heel. Okay. The one that caused the overturn will be the lateral pressure, right? Come off here. And then the one that resists the overturn will be the weight of the sole above heel. Okay. So it means ni. Okay. This part. Yang ni akan help to resist the overturn, which come from here, from PA, PH and from PA lah. Okay, PA is the resultant lateral pressure. Okay, kenapa dia resultant? Because of the triangle is not dia ada slanting sikit. So there's a resultant. So from resultant dia akan dipecahkan kepada Y and X. Okay, where Y denoted by PV here and X denoted by PH. H is horizontal, V is the verticals. Okay. So factors that contribute the resistance ataupun MR will be weight of the soil above hill, nombor 1 tadi, weight of the concrete. So the weight of the concrete, okay. I highlight okay. Yang highlight kuning ni, the one that will help to resist the resultant lateral pressure. Okay, this part, berat tanah ni akan membantu untuk resist the soil, the lateral, and then the concrete. Yang ni concrete. Ini adalah concrete mass. Okay. And also PV. Okay, what is PV? Okay, what is PV? This is the PV. PV is actually the lateral earth pressure, tapi yang sudah dipecahkan kepada Y and X tadi kan. PV ini adalah Y lah. Okay, in Y. Okay. Ada explanation kat situ kan? PV is the vertical component of active force PA. This is the PV. PA sin alpha. So alpha, kena ingat balik alpha tu apa? Alpha adalah the angle for the ground level. So this is alpha. Okay. Okay. So MR will be PVB, PA sin alpha B. B is the width of the slab. Okay. Cuba you tengok yang ni. In a summary, the factor of safety overturning will be, this is the moment resisting the lateral pressure, and then this is the moment of overturning. Moment overturning. Okay, bila you tengok gambar ni, okay. Okay. Apa, ada soalan tadi? Sekejap Madam, is the trapezoidal loading below the retaining wall due to the resisting weight of concrete? Trapezoidal loading below the retaining wall. Yang ni ke? Is it yang tu? Just asking. Yeah. Okay. This is due to the bearing pressure. So this actually the pressure induces on the apa ni? Apa orang cakap? acting at the below of the retaining wall. Okay, jadi you kena kira yang kat sini Q heel. Okay, ini Q toe. Yang ni bearing pressure. Sekarang kita tak sampai tu lagi. Saya baru explain on the overturning. Nanti kita tengok yang ni. Okay. So sebenarnya the Q at the toe larger than the Q at the heel. Okay, nanti kita tengok balik yang ni. Kita tengok overturning dulu Okay. Okay. Okay tak? 6629 ni. Okay. So kita tengok overturning dulu. So this part will be the one that resists. Ini yang resist. Ini yang resist. Tengok Ini yang resist. Actually ini pun resist. Tapi ni tak consider lah dalam ni. Dia sebab kita nak kira macam mana kita nak kira lah moment nanti. Okay. So this is apa ni? The shapes of the concrete kan. Dia macam-macam macam ni. Okay. Kita akan pecahkan kepada bentuk yang kita boleh determine the resultant forces. Let's say kalau bentuk segitiga macam ni, nombor 3 ni, it will be 1/3, right? 1/3 from the, kita nak exist dia, centroid. What we call it? What's the forces that acting on the centroid? Okay, yang ni tengah-tengah, yang ni pun 1/3 kan? Nanti kena check 1/3 daripada sini ataupun 1/3 daripada sini. Ingat tak? The centroid, the force will be exerted on the centroid. I think from here, if I'm not mistaken, nanti you check balik ni 1/3. So sekarang nak cari moment ni. Nak cari moment resisting. Kalau moment kena ada force darab distance, right? Distance. So sekarang yang ni, let's say this is the force, the weight. Okay, so you kena jadikan toe ni sebagai tempat yang dia akan topple. So the distance will be here. Madam, is the angle at Q heel also alpha? Yes. Alpha. This is alpha. Okay. So sekarang macam mana kita nak kira moment ni? Daripada sini weight, this is the X. So this one is the X. This one macam ni Okay. Dia akan resist ni. And then the one that cause the destabilization will be pH, right? pH akan tolak macam ni. It will be 1/3 H. Okay? You can check it further dekat sini, section ni. Untuk calculate the MR and the MO. Ni area dia. The weight of unit. Okay. So yang ni ada refer to the soil, right? And then C, it will be referred to the concrete. Okay. So the moment arm measured from C or the toe, it will be X1, X2, X3. So baru you dapat moment. Okay. Okay, for the sliding along base, okay, you gonna check the capacity. Macam mana nak delete? Okay. Sliding, this R must be larger than pH. So how? Sum of horizontal resisting forces must be larger to get a higher factor of safety, must be larger than the driving forces. So the resisting forces at the base, we know that the shear strength is tau sigma tan phi plus C, right? The shear strength. The shear strength comes from friction forces below the base. So the resisting forces due to the shear strength at the base actually referred to R dash S area of the section, B times 1. Why is 1? Because 1 meter into in the length of wall. So the one that you saw just now, macam ni kan, is actually a 2D pictures of retaining wall. Tapi sebenarnya into this screen, the wall is very long. So how to calculate these existing forces based on the 1 meter into the screen. Itu masuk ni lah 1 meter in the length of the wall. Kita kira by meter. Okay. Then you masukkan dalam rumus tadi. Okay. So B sigma tan phi plus BC. So B sigma is also equal to the vertical. Okay. Kalau you tengok balik sebelah tu. Okay. Ini. This one. Okay. So R dash equal to vertical tan phi plus vertical forces from, this is the weight of soil behind the concrete. Tambah BC. And then plus the passive pressure. Passive pressure is actually the soil in front of the retaining wall. You kena ingat balik apa passive and active ni. So the total of resisting forces are the self-weight of the weight of the soil just behind the retaining wall, multiplied by the friction angle of the material plus the cohesion kalau ada plus the passive pressure. Okay, ini kita tengok gambar. Okay, the resisting forces for the R, the total of the R, we have to make sure this R will be larger than pH. Much more larger in order to avoid the sliding. So how this R, the pecahan is actually come from the material that retain at the back of the retaining structure multiplied by the frictional angle. Ingat tadi the frictional angle of the soil material plus the cohesion kalau ada plus the passive pressure acting in front of the wall. Okay. So normally this will be effective sekiranya the height or the D here is about more than 1 meter. Kalau rendah sangat dia tak ada effect pun. Okay. So normally 0.5 or less than that to 1 meter, in the design itself we don't consider the passive pressure. Dia tak cukup tinggi untuk melawan ataupun introduce a passive pressure into the concrete wall in order to help the resisting. Okay, kita abaikan saja. Kalau diterlalu rendah, kalau 0.3 meter, 0.2 meter. But if it's a significant height at the in front of the wall, it will be helping the resisting forces. Okay. Okay. So if walls do not yield, okay, kita pergi balik yang tadi lah. Habis lagi. Kenapa? Macam mana nak tutup benda ni? Okay. The causing forces is actually the driving forces PA cos alpha lah. Okay. Jadi kalau nak dapatkan faktor dia, ni FR divided by F driving. So the factor of safety normally is minimum 1.5. Less than this, it will be felt. Okay. We have to consider the apa ni, yang key ni tadi, in order to increase the SOL. Okay. So ini the last one will be the bearing capacity, the one that asked me about the pressure below the SOL tadi. So bearing capacity, vertical pressure transmitted to the SOL by the base slab should be checked against the ultimate bearing capacity of the SOL. Okay. So this is the pressure diagram just now you get. So in the previous slide, Q toe and Q heel, okay, maximum and minimum pressures respectively at the ends of the toe and heel section. So Q toe and Q heel is actually the vertical pressure transmitted to the soil by the base. So kalau vertical pressure ni terlalu besar, it will be ada settlement lah, excessive settlement. So in order to calculate this, how? So net moment of forces about toe will be moment of resisting tolak moment of returning kan. So R is line of action of resultant forces of delta V and PH. So R intersect base slab at E. So gambar ni kita tengok gambar ni at the base of the wall. Okay. B. Okay, VH. So this R. So we want to check whether this pressure tak terlalu besar. Okay. How? R is line of action of resultant of forces delta V and PH that R intersect base slab at E. So CE equal to X bar M net over delta V. Hence eccentricity of R is E equal to V over 2 tolak X bar. Ni at the base of the wall. Tengok yang kat sini. Nak tengok eccentricity ni enough to, it's not that large lah. Okay, so this is B over 2. This is B, width of the base. Okay, width of the base of the retaining wall. So this is the toe and this is the heel. So we are assuming the R just now, the resultant forces act due to the vertical of the soil and the wet concrete. Okay, and the H at the friction angle, it won't be too much in order to avoid the excessive settlement at the base. Okay, so the eccentricity must not exceed B over 6. So the resultant forces, it will act at some eccentricity. Tapi eccentricity ni tak boleh besar daripada B/6. Okay. Supaya tak best pressure distribution ni tak terlalu besar. Okay. So this is the limit of it. Okay. Yang ni tak boleh besar daripada B/6. So in order to calculate the Q distribution under the slab, so this are the rumus. Delta V over A plus minus M net Y over T over I. So the M net here is referring to the delta V multiplied by the eccentricity. And I here is the moment of inertia of the base. Okay, normally is B's apa ni? Bukan squared. B the power of 3 multiplied by 1 is the length into the wall divided by 12. So this is the moment of inertia of the base. And Y here is actually referred to B/2. Okay. So delta V comes from the same as the one that we calculated before. Okay. So we know that at the base, this is the distribution of the vertical pressure transmitted to the foundation ataupun to the soil below the base. Okay, ni base. Okay. Ini adalah dekat toe, ini dekat heel. So the maximum Q will be at toe, the minimum will be dekat heel. Okay, so these are the formula. Okay, so note that the vertical pressure includes the soil weight yang berada di belakang. Let's say this is the cantilever kan. Okay, ingat tak yang di belakang ni? You kena consider ni. Ini adalah refer to the delta V, not only the concrete. Yang ni pun membantu juga. Okay, so when E is more than B/6, Q minimum is negative, which means dia macam ni lah. Yang ni kat bawah, dia macam ni positif kan? But kalau ni terjadi, it means the pressure will be like this. Okay, ini negatif. Tensile at heel. So tensile mean yang ni akan uplifted lah, heave. Okay, so in order to avoid that, okay, sebab yang ni terlalu besar kan dekat heel, dekat toe, and ini negative, the pressure will be, instead of macam ni, the pressure will be like this, something like this. Ni akan jadi negatif. Sol ni akan naik ke atas. Thief. Okay, fail lah. Because of its overturning. Trying to overturn. Yang ni dah fail lah. So how to check it? The Q ultimate over Q max. Q ultimate is the relationship of varying capacity of shallow foundation. Okay. So how to calculate the Q ultimate? Guna rumus ni Okay. Guna rumus ni. Okay. It's already 9:30. It actually one example of to check the overturning, sliding and the bearing capacity. Okay. Rasanya kita tak sempat nak discuss on the assignment lah. I want to go through this one example. Okay. Sebab assignment pun lebih kurang macam ni, but it's a lot easier. Okay. So these are the figures of cantilever retaining wall. Okay. I think this example is from Braja. Okay, this is the sizes of the cantilever wall, 0.5. Cantilever wall, which means the reinforced concrete. Okay, so this is the base. Okay, these are the dimensions. So ingat, untuk kira tanah yang untuk resist the soil, we know that this is the lateral earth pressure, right? That introduce ataupun that try to destabilize the retaining wall. Tapi tanah yang berada di belakang ni adalah diconsider untuk helping to stabilize the soil. Okay, you have to remember that. So normally the soil parameter will be given to you unless it's stated that you have to assume. Okay, kalau tak ada dibagi, you assume lah. So this is the soil for the foundation. Ini adalah the retain soil. These are the parameter that you need to know in order to use the formula later on. So now the total H bar here will be the total H. You can see H1 is from the H that introduced from the sloping ground level. So the angle here or the alpha is 10, and then H2 is the height of wall. H3 is the height of base. Okay, yang ni adalah due to the sloping angle. Okay, yang ni kena kira betul dulu. Okay, so the passive ataupun yang jadi passive pressure here, the depth will be 1.5 meter. Okay, so this is the examples. Okay, the Rankine active force, you can refer to the notes kalau tak nampak. The Rankine active force per unit length. So this, in order to calculate the lateral pressure, untuk contoh ni, dia guna Rankine theory. Okay, Rankine active force per unit length of wall PA is equivalent to 1/2 gamma HKA. Okay, darab dengan apa ni? And the friction angle will be 30 degree, right? And alpha, the sloping and the ground level will be 10 degree. Ka is equal to 0.350. Ka ni daripada yang calculation 1 tolak sin phi over 1 tambah sin phi. Yang ni you kena tengok balik nota yang sebelum ni in order to calculate the Ka. Okay. So PA will be here. 1/2 gamma. Gamma ni yang gamma retain tadi. So this is the height. Dikuasa 2 didarab dengan Ka. So this is the PA. Okay. So PA here, you noted that the sloping ground level will introduce a sloping ni juga kan. Okay. So the force acting into to the wall at the back of the wall is actually slanting. Jadi resultant ni you kena pecahkan kepada y and x dahulu in order to calculate. Okay. So this PV and PH is already being from the resultant PA lah. Okay. So here the angle here will be representing the sama angle dengan alpha. Okay, you can see P sin 10 degree, PA cos 10 degree. So PH will be the one that caused to overturn or slide, but PV the one that will resist or help the resistance. Okay. Jadi kena ingat yang mana satu resist, yang mana satu yang akan tolak the wall. Okay, yang ni kena betul dululah. Okay, jangan confuse. So first, we have to check the overturning whereby tadi saya dah tunjukkan you kena construct a table lah. Sebab kita nak kira the weight of the concrete didarab dengan level arm. Level up. Sebab kita nak kira moment with respect to toe here. So the weight of the concrete didarab dengan distance ni will be the moment. Satu. Yang ni the weight of the sole at the back didarab dengan from here the centroid to the toe will be the moment. Okay, kena kira satu-satu. Kalau kamu punya konkrit tu besar, you kena pecahkan. Okay, let's say konkrit kamu bentuk dia macam ni, is normally like this lah. Or either is lanting here, so you kena pecahkan kepada bentuk di mana you dapat determine the centroid. So this the centroid will be determined at 1/3, ini akan determine at half, yang ni akan determine the 1/3, yang ni akan determine the half. So X tu kena kira kejap. With respect to toe. Yang ni X ni, X ni, X ni, semua kena kira to the toe. And also the sole at the back. Ingat. And also sole at the back. Salah. Okay. Faham I hope you understand lah. Okay. So now this is the first one. You have to go through one by one. Saya rasa saya tak sempat nak go through satu-satu. But you have to able to differentiate the moment of overturning and moment that cause the overturn and moment that helping to resist the overturning. So sekarang the rule of thumb ataupun the factor of safety must more than 2. So this will be okay. So design will be okay. The second one, you have to check the sliding based on this is not the equation ni tadilah. The equation you kena tengok equation yang sebelum ni tadi So this is the you can see delta V tan V plus BC plus PP is the same thing lah. Okay. Kenapa you tengok ni ada lain sikit? You kena tengok buku teks berajar what is K1 and K2. It's actually referred to the sebab ada bentuk of the shape of the retaining wall tadi Okay. Dia tak lurus. So bawah ni adalah sliding forces. Okay. So ini rumus dia. And PPD is 1.5. Okay. So now this is your PP. This is your cohesion. This is your delta V comes from the frictional angle. So this is your PH. Okay. So the design is more than 1.5 is okay. So sliding. Okay. The third one, bearing capacity failure. Di mana kat bawah base tadi, let's say, bawah ni dekat toe, the maximum will be here, the minimum will be here. Okay, you nak check sama ada berat konkrit ini, okay, not more than the bearing capacity of the soil. Okay, ini tujuan untuk kira bearing capacity failure. So how to calculate it? You have to, you have your V and H kan? This is the resultant acting, comes from the lateral earth pressure. So let's say we are putting this one at the base. Okay, this is the center at the base. of the wall, of the retaining wall. Ini V, ni H. So ni, you akan calculate the eccentricity that will be causes the contribute to the bearing capacity calculation, which is the eccentricity. Ini adalah dia punya rumus. Okay. So delta V 470.45 is actually calculated as before. Yang ni yang moment resistance tolak moment overturning. You tengok this value actually calculated here just now. Moment R, moment overturning. Okay. Perasan tak? Yang ni you dah kira tadi dalam table. Yang ni moment overturning. So this one 470.45, the one that you kira at the front. Where is it just now? V, your V. Where's your V? Here. Okay. Tengok Yang ni dengan yang ni. Kamu guna balik untuk kira bearing capacity. Here. Okay. So, baru dapat eccentricity. Yang ni kena tak less than V over 6. Should be okay. So, this is the formula for Q, tau and heel. So, tau will be referred to tambah. Heel will be referred to the minus. So, this is the tau and this is the heel. So, make sure tau is the highest one. Here is the minimum one. So in order to calculate the FOS, QU ultimate must not more than Q besar daripada Q max. Q ultimate is the kekuatan tanah, comes from the kekuatan tanah or the bearing capacity of the soil. Okay, how to calculate it? This one actually using the formula where we consider all the shape of the base. Okay. So yang ni semua daripada table.